Hello guys, it's my hope that you're doing well. Welcome back to Miss Fountain channel. In this session, we're going to look at forensic toxicology. We're going to begin by a brief definition of some terms. And the first one is toxicology, which is the study of poisons. The second one is poison, and find that we're going to define poison as any substance which, when taken in sufficient quantity, will cause ill health or death. As long as it's taken in sufficient quantity, anything can be poisonous, including water. Because when you ingest large amounts of water, there'll be fat or electrolytic imbalance in the body. Forensic toxicology is concerned with the detection and estimation of poisons in tissues and body fluids obtained at autopsy, or occasionally in blood, urine, or gastric material obtained from a living person. Toxicology is the study of poisons, and they don't have to come from the dead. It can also be samples obtained from a living person. And an autopsy is a scientific procedure where dissection is followed by examination of tissue. Chemical, bacteriological examinations may be required, and the results are documented in a written reports and photographs. It is done by a pathologist, and it's a process that begins with the identification of the victims all the way till the cause and manner of death are identified. And we're also going to have a brief history of forensic toxicology. Find that until the 19th century, physicians, lawyers, and law enforcement officials harbored the notions about the signs and symptoms of poisoning, where they traditionally believed that if a body was black, blue, or spotted in places or smelled bad, it was a result of poisoning. The death was brought about by poisoning. And other mistaken ideas were that the heart of a poisoned person could not be destroyed by fire, or that the body of a person dying from arsenic poisoning would not decay. These are some of the beliefs they had in those earlier years. In the year 1775, Carl, a famous Swedish chemist, discovered that white arsenic was converted to arsenic acid by chlorine water. And the addition of metallic zinc reduced the arsenic acid to poisonous arsenic gas. If gently heated, the evolving gas would deposit metallic arsenic on the surface of a cold vessel. In the year 1821, Sevillers used the decomposition of arsenic to detect small quantities of arsenic in stomach contents and urine in poisoning cases. In 1836, James Marsh, a chemist at the Royal British Arsenal in Woolwich, used the generation of arsenic to develop the first reliable method to determine an absorbed poison in body tissues and fluids like the liver, the kidney. And in the 1800s, witnessed the development of forensic toxicology as a scientific discipline. In the year 1814, Matthew Ophelia, the father of toxicology, published Treat the Poisons, the first systemic approach to the study of the chemical and physiological nature of poisons. We have other happenings in the in the history of forensic toxicology, which we are going to look at deeply in another video. We have the steps of toxicological investigation of a poison death. This takes place in three main steps, and that the first one is obtaining the case history and suitable specimen. The second one is the toxicological analysis. Then you have the interpretation of the results of the analysis. Case history and specimen collection. Toxicologists must be aware of the age, sex, weight, medical history, occupation of the deceased, any treatment administered before death, gross autopsy findings, drugs available to the decedent, time interval between the onset of symptoms and death. These are very important details because remember the samples that we have here are limited, and the toxicologist has only a limited amount of material on which to perform his analysis. Therefore, it's imperative that before beginning the analysis, he or she is given as much information as possible concerning the facts of the case. And find that some poisons include prescription drugs, drugs of abuse, commercial products, gases, etc. We're going to look at the exhibits collected at autopsy for toxicological analysis. We have the specimen, the quantity, and the toxicant salt. We're going to start with the adipose tissue. The quantity that's required is 200 grams, and here we look for insecticides and their penton. In the bile, we take all that is available, and the toxicant salt is contained in morphine. Blood, 15 milliliters are required, and what is analyzed for is alcohols and carbon monoxide. The brain, 500 grams is required, and volatile poisons are salts. When it comes to kidney, it's a whole organ, and heavy metals are salts. We have the liver, 500 grams are required, and here it's for the analysis of most toxicants. We have the lung, that is the whole organ is required, and what is analyzed is methadone, gases, and inhalants. When you have stomach and intestinal contents, all that is available is taken, and what is all toxicants that are taken orally. We have urine, all that's available, and most toxicants are sold. We have uterus humor, and it's taken all that's available, and digoxin, electrolytes, and glucose are sold. In collection, the pathologist labels the container with different details, and these are some of them: date and time of autopsy, name of the decedent, identity of the sample, and the signature of the pathologist. And specimen should be collected before embalming. This is because embalming may destroy or dilute the poisons that are present, rendering their detection impossible. For instance, cyanide is destroyed by the embalming process, and conversely, we have methyl or ethyl alcohol may be a constituent of an embalming fluid, thus giving a false indication of the decedent's drinking prior to death. Go to the next step, which is toxicological analysis. Before the beginning Before beginning the analysis, the toxicologist must consider several factors. That is the amount of specimen available, that's very important, the nature of the poison source, and the possible biotransformation of the poison. Especially that the toxicologist is working with a limited amount of specimen, the toxicologist must devise an analytical approach which will allow the detection of the widest number of compounds. In cases involving oral administration of the poison, the gastrointestinal contents are analyzed first, since large amounts of residual unabsorbed poisons may be present. The urine may be analyzed next, as the kidneys are the major organ of excretion for most poisons, and high concentrations of toxicants are often present in urine. Following absorption from the gastrointestinal tract, drugs or poisons are first carried to the liver before entering the general systemic circulation. Therefore, the first analysis of an internal organ is conducted in the liver. If a specific poison is suspected or known to be involved in death, the toxicologist chooses to first analyze those tissues and fluids in which the poison concentrates. For example, if the toxicologist is sure that an insecticide was involved in the death, they're going to analyze the adipose tissue. If they're not sure, they'll follow the process. And biotransformation is a term that is used to denote the conversion by the body of a foreign chemical to a structurally different chemical. And the new chemical is called a metabolite. Find that the biotransformation of a drug or poison, usually, but this is not always the case, result in the formation of a physiologically inactive substance, which is more readily excreted from the body than the parent compound. It is necessary for a toxicologist to isolate and identify the poison first. Find that there are 5 groups of poisons, and the group 1 is gases. Find that most gases of toxicological significance are not detectable in autopsy specimen. However, some may be isolated from blood or even lung tissue by aeration processes. And sometimes air samples are collected at the scene of exposure. Second group is steam volatile poisons. Compounds in this group are isolated by steam distillation. The sample could be blood, could be urine. Is made acidic with HCl, that is hydrochloric acid, or basic with solid magnesium oxide. A stream of steam is passed through the sample, and the volatile poisons are distilled off in an aqueous distillate. The third group is metallic poisons. Metals are isolated from tissue by destroying all the organic matter comprising the tissue. The tissue may be destroyed by excessive heat, that is dry ashing, or by boiling with concentrated acids or strong oxidizing agents, that is wet ashing. Various methods may be used to identify specific metallic poisons remaining in the ash. The fourth group is non-volatile organic poisons, and find that this group contains most of the drugs of interest to toxicologists. Compounds in this group are usually present in tissues only in minute quantities. Some drugs, like the barbiturates, may be directly extracted from tissue. homogenates by organic solvents. However, many compounds are often separated from the bulk of the tissue matrix by preparing a protein-free filtrate of tissue. The filtrate is then subjected to selective extraction with organic solvents under varying conditions of acidity. And using such technique, drugs are isolated into 5 subgroups, that is, strong acids like the salicylates, we have weak acids like the barbiturates, we have neutrals like meprobamate, we have bases like codeine, we have amphoterics like morphine. And group number 5 is miscellaneous poisons. And this group includes all poisons not classified in the 4 groups. And the substances included in this group are inorganic anions, highly water-soluble organic ions, and organic compounds insoluble in water or alcohol. There are major tests that are carried out in the analysis process, and color test is one of them. And we find that a color test is a chemical procedure in which the substance tested for is acted on by a reagent, which causes a change in the reagent, thereby producing an observable color or color change. This color test may be used to determine the presence of specific compounds or just a general class of compounds. And we find that these procedures are usually rapid and easily performed. Another test that is used is microdiffusion test. And microdiffusion analysis is used for the rapid isolation and detection of volatile poisons. Other tests that are carried out in this analysis include the chromatography, thin layer chromatography, gas liquid chromatography, high performance liquid chromatography, spectroscopy, mass spectrometry, immunoassays, etc. All those are some of the tests that are used in the analysis of toxicological samples. The final step is interpretation of the results. Toxicologists interpret the findings as to the physiological effects of the toxicants on the decedent at the concentrations found. In the final step, that is in the interpretation of findings, we find that this is done in a report. A report is presented. In complete interpretation of analytical results requires consideration of postmortem redistribution, the nature of tissues used for analysis, genetic considerations, drug tolerance, possible effects of the presence of multiple drugs. Those are some of the factors or considerations that a toxicologist has to make when interpreting the findings. And that's when they rate their reports ready for submission. Thank you. I hope you enjoyed this session. Kindly like, share, subscribe, and stay tuned for more. Thank you.